Welcome to the flipped classroom lesson for section 4.2, which is entitled Exponential Functions. Up to this point, we've taken a look at polynomial functions and rational functions in chapter 3. So the third type, exponential functions, is what we're going to start to focus on at this point. So take a look at our essential questions. These are what we want to be able to answer by the end of this section. First of all, what does the rule of an exponential function look like? So by rule, we mean the general form of an exponential function. What is that going to look like? The next essential question is, what would the graph of an exponential function look like? Okay, so again, this is just the general appearance of exponential functions. Third, we're going to talk about how to solve an exponential function. Okay, fourth, we're going to actually figure out how to create the graph of an exponential function. So not just what it looks like, but how to actually draw the graph from a specific function that we're given. Fifth thing we're going to do is talk about the inverses and whether or not exponential functions have those and what they would look like. And then finally, we're going to end with some of the applications for exponential functions, which are the word problems that involve them. Okay, so I'm not going to go through the next 2 pages, but you can stop and take a look if you want. You will get your no-do sheet if you haven't already. So these are what you're going to be able to know by the end of this section, and of course, following that, what you're going to be able to do by the end of the section. So again, feel free to take a quick look, but I'm going to skip them for now. Okay, so back to polynomials, which we did in chapter 3. Polynomials had the basic form of y equals x to some variable exponent. Okay, so depending on how many terms we actually have, our most basic form for a polynomial. Okay, we deal with a base, that's a variable. Okay, so that would be our x value here. Variable base. And then our exponent is where we have a real number. Okay, so again, the base was our variable. What we're going to consider now is a function in just a slightly different form. Okay, so y equals a to the x. So for this one, our base is now the real number, and our variable is the exponent. So we're switching those two around when we talk about an exponential function. Okay, just to take a look at a few examples of what these might look like. Okay, at the top we have y equals 1.04 to the power of 4x. If you take a look at the second one, we have y equals 3 to the power of negative x, or the opposite of x. And then the last one that we have down here, y equals 2 to the x. We're actually going to start with this one, which is a very basic exponential function. And we're going to really take a look at this one and see what kind of values we come up with for this function. Okay, so on the left, you'll notice a table where we have values ranging from 0 to 7, and then the right 0 down to negative 7. Okay, so we're going to calculate all of these and then take a look at that when we actually graph all of these points. Okay, so starting with f of 0, which we are going to use twice here. But when we plug in a 0, we have 2 to the 0 power, and anything to the 0 power always equals 1. Okay, so I'm just going to fill in a 1 for both of these values. Okay, let's do the positives first. So the function, we can put a 1. We have 2 to the first power. So we know that that's 2. Okay. So now if we plug in a 2, we get 2 to the second power, which we know is 2 times 2, or 4. Okay. We plug in a 3, we get 2 to the third power, which is 2 multiplied 3 times, or 8. So what we're essentially working with here are powers of 2. Okay, if I'm going to go continue the rest of this table, I would just keep doubling the value. So 2 to the 4th power, when we plug in a 4, is 16. 2 to the 5th power is 32, 2 to the 6th power is 64, and finally 2 to the 7th power is 128. All right, so now we're going to take a look at the negative side. Okay, I'll do a couple of those out for you initially. So plug in a -1, it's 2 raised to the exponent -1. And anytime that we have a negative exponent, we have to do the reciprocal of the power. So we have 1 over 2 to the 1st power, and now it becomes a positive exponent, and that's simply 1 over 2. Okay, I'm just going to scroll down a little so we have some more room here. All right, so now if we look at the function at -2, it's 2 to the -2 power. So again, we know that we could take that and flip it so that we have the reciprocal 1 over 2 squared, which is 1 over 4. We already calculated 2 squared above, okay, when we did the function at 2, so we get 1/4. All right, let me do one more and then we'll take a look at a pattern. So the function at -3, 2 to the -3 power, 1 over 2 cubed. And again, we already did 2 cubed above. We know that that's 8. So this is 1 over 8. Okay, so what you should start to notice is that what we have is a pattern going on here. When we look at +1 and -1 in this function, values were 2 and 1/2. Okay, 1/2 being the reciprocal of 2 and vice versa. The same thing happened with 2 and -2. We have reciprocals. Okay, 3 and -3, we have reciprocals. So it makes sense that the same should apply for the rest of the values, which means that when we plug in a -4 into the function, we get 1 over 16. -5, 1 over 32. -6 would be 1 over 64. And -7 would be 1 over 128. Okay, so we've now filled out our chart. One thing that we might be able to take notice of here before we actually start to create a graph is that all of the values that we get when we get an output for the function, all of these values are positive. So our entire graph is going to be located in the top half, or in quadrant 1 and 2. All right, so what I'm going to do now is actually take the graph and plot some of these points that we have below. Okay. Okay, so I paused the video for a second and actually set up our axes. And I'm going to use this along the x-axis. I'm going to separate them out a little more. You'll see why in a second, but I went by 1s for the y-axis. Okay, so if I'm going to start by plotting the first point I found, the function at 0, that value was 1. So I'm going to put my point right there on 0, 1. Okay, let's go in the positive direction first. So f of 1 we know was 2 to the 1st power, or 2. So I can plot that next point. When I plugged in a 2, 2 squared is 4. When you plug in a 3, 3 squared was 9. So 3, 9 is the next point. Next point, when I plug in a 4, I get 16. Okay, and f of 5 was 25, which is going to go off the graph, so I'm not going to plot that one. Okay, but now I'll go on to the left for -1. Remember, that was the reciprocal of the function at 1, so that was 1/2. Little low. Okay, then I go to -2. So again, reciprocal of the function at 2, and since 2 equals 4, we have 1/4. Okay, then for -3, it's 1/8. Okay, -4, 1/16. So we're really just getting closer and closer to 0. -5 is 1 over 32. So it's difficult to show the difference, but again, we're getting closer and closer to that 0 value on the x-axis. Okay, so if I'm actually going to go through and draw the line, and we have our exponential function graph. Okay, so this is, again, the graph of f of x equals 2 to the x power. So what we're going to do now is talk about a couple things from this graph. Okay, so on the next slide here, we want to see or talk about what the domain is, the range, the zeros, the holes, x-intercepts, y-intercepts, and asymptotes. What we were looking at before when we were doing graphing. So starting out with the domain, if we go back to the graph, we can see that any x value can be plugged into this function. So our domain is all real numbers. Okay, next for the range, again, we'll go back here. So for our y values, the graph is not going to ever reach 0. Okay, we know that it's just going to keep being the reciprocal of the number for the positive x value when we head towards the negative x value. So we know that 0, it has to be greater than or equal to 0. Okay, so using integral notation, function can go from 0 up to infinity. All right, zeros. Zeros, we know, are when the function equals 0. And since that did not occur, we know that there are no zeros for this function. Okay, a whole would be if we had the same factor in the numerator and denominator of a fraction. Since we do not have a fraction here, there are no wholes. All right, next up, x-intercepts. Again, since we have no zeros, there are no x-intercepts. Not sure how that happened, but that's okay. Now for the y-intercepts. Okay, if we go back, it crosses the y-axis right here at 1. So our y-intercept is at 0, 1. And finally, asymptotes. Okay, when we go back, if we look at the x-axis, and as the function approaches, as x approaches negative infinity, the function approaches that x-axis. So we do have an asymptote on the x-axis. Okay, so the way that we write that, as x approaches negative infinity, the function approaches 0. Okay, it approaches that x-axis. Now, if we take a look at as x approaches infinity, the graph does go up, and it will approach infinity, so we don't have an asymptote over on the right. We only have the one over on the left. Okay, there is no vertical asymptote here. All right, we can always find another value for x, so therefore we do not have a vertical asymptote. Okay, so that's some of the information we got from our first graph. Now what I want you to think about is how to make a generalization about what happens for an exponential function. So this is going to be the end of our video for today, but in class tomorrow or whenever your next class is, come in with some thoughts about a generalization for the exponential functions. So try considering any exponential function. So again, we're talking about, sorry, little technical difficulties here. Okay, so when we're talking about our exponential functions, we're thinking of f of x, where we have some number, let's use c, some number c raised to a variable exponent, and consider when c is a number greater than 0. Okay, think about the domain, the range, the zeros, the x-intercepts, y-intercepts, and asymptotes. Do you think that there are any generalizations for any of those categories? And if so, what are they? Is something going to occur every time, or will it be different depending on the value for c? Okay, so we will talk about that during our next class, but that is the end of the video for 4.2.